Before going to a live debugging demo for finalization survivors, let's recap our subject. Consider there are two .NET objects on the heap. One is fully managed one and the one is a finalizable object which has implemented a destructor. Consider both are unreferenced now. Then when a new GC comes to the heap, the fully managed object will be garbage collected. But we have learned that a finalizable object will be escaped from his first GC and it will become a survivor object. We have also learned the finalizable object will be moved from finalization queue to the FR queue. This object will be picked only by the next GC operation. So we know that a finalizable object needs an additional GC to get destroyed compared to the fully managed object. We will do a live demo to prove these particular concepts. But before going there, we would like to discuss one more point, that the finalizable object is now getting an additional time to get destroyed. What would be the implications of this? To discuss this, let's go to the another section. Let's consider a finalizable object has a scarce resource as its data member, and the user prefers to release that member as soon as its usage is over. I can think about a scarce resource example as opening a database connection, because keeping too many connections will affect the application performance. But in our case, the finalizable object survives its first GC, and consider the next GC arrives only after a time interval. Let's say 10 minutes. So that many minutes, the scarce resource member is going to be alive and hold unnecessary. This is not a favorable situation. But in the case of a fully managed object, the advantage is that the object will be picked in its first GC itself and this particular scarce resource will be released. But all is not lost. There is a way to make the finalizable object behave like a fully managed object using a disposable pattern. We will discuss that in our next chapter. Now we will do a demo to prove this particular finalization survivor concept. Opening the test application. Here there is a demo for finalization survivors. According to this demo, two phone users are browsing their mobile internet on their phones. Applying the buttons, users started using the mobile data. We can show you the button code. Here, as per the code, there are two .NET objects created for using the data. The first one is a fully managed one and the next one is a finalizable object. User 1 is using the fully managed object for browsing the internet. User 2 is using the finalizable object. Now let's observe these objects in the application's memory. For that, we have to connect the application with the debugger. Opening a 32-bit debugger, attaching the application, now the application has been attached. The first thing, I have to load a DLL, SOS. SOS DLL is required for debugging .NET application with debugger. DLL loaded. Now let's inspect our objects. Dump heap minus type manage net usage object. We know that we have created only one. Yes, we saw the address of this application. Copy the object address. We are going to do some preliminary action on this. First of all, we will see how the object is being routed. We have learned a command gc root and provide the address. This command will help to see the references on this object. Manage net usage object is being connected with the phone user. That's what we have done here. We have created a manage usage object and connected with the phone user. Now we will see where this object is been available in the memory. For that, we have to use gcwhere, provide the address. This object is been available in the generation 0. Currently, we have done our operation on a fully managed object. We have also created another object which is a finalizable one, manual net usage. Let's do the same procedure on that object too. Dump heap minus type. This command will print all the manual net usage object from the heap. We know that we have created only one. Yes, one. Copy the address. Let's find it out in which generational heap it resides. GC where, providing the address. This is also staying in gen 0. Now let's see how it is been routed. Use GC root. Even this object is being connected to the phone user according to our button code. We have created net usage classes and user1 is been referencing that. Now let's see what is the effect of GC on these objects. For that we have to go back to the application. Sorry, before going to the application for applying GC, we have to prove one more thing. Currently both objects behave the same. They are existing the same heap and they are referred by similar object. But we know that this manual net usage object is a finalizable object. So this must be having a reference with finalizable queue. Let's print the FQ. Finalizable queue. Let's search. Yeah, manual net usage object is been available in the finalizable queue. Now we can go to the application. Let's apply a go command. So now application has got the command. Here we would like to release the phone from the user. By applying this button, users stop browsing. This commands will get executed by applying this button. Data usage both are equal to null. Now let's apply a go command to give the control back to the application. Application got the control. Now we wanted to release the object from the user. Both users stop browsing. I will show you this button command. Apply go command to give the control back to the application. Now we want to release the object from the users. For that we have to apply this button. Both users stop browsing. I can show you this button code. We have unreferenced the manual net usage and managed.net usage objects into null. Now we can apply the GC. Consider that a garbage collector came to this application. It has happened. Let's see what happened to these objects. For that we have to connect back the application to the debugger. Debug break. We have previously executed where these objects were. We will do the same command. Dump heap manage net usage object. 0. That means the object has been picked by the previous GC. This is a fully managed object. Let's see what happened to the other object. Manual net usage. According to us, this is a finalizable object, right? It still exists, right? Now let's see where this object resides. Copy the address. GC where command. This object is in the generation 1. So what we understood is that from the first GC, the fully managed object is being completely removed, but GC couldn't pick the manual net usage object. It has still alive in the application. So ultimately consider that the person who is using the manual.net, according to him, the object usage is been over, but still he is using the mobile data, right? So he is using a scarce resource. So what do we do now? This object will be killed by additional GC. Let's explore that. Apply a go command. Consider 10 minutes over. We are applying one more GC, or one more GC came to the application. GC action happened again. So since the second GC happened, let's see what happened to this object. Again trying to print. Now this is been removed. That means the finalizable object needs at least 2 GCs to get it picked by the GC. So that much time this object is been residing in the memory. We have proved our theoretical concept now that finalizable object, or the object which has implemented the destructor, will live on additional lifespan and the object will be moved to the generation 1. Thank you. If you like this video, we request our users to subscribe to our YouTube channel. We also request users to download our free Android app that contains the video tutorial or .NET CLR internals. This is the app. This will help the users to read during the traveling. This is the link. We'll provide the link in the video section comment.